Good morning, ladies and gentlemen. My name is Nikola Schmidová, and I'm from Czech Technical University in Prague. And I would like to present our work concerning damage detection of carbon fiber rings for polymer filament wound tubes using electrical resistance measurement. At the beginning, I would like to apologize for quality of some graphs I will present because we were prepared for the poster presentation only, so we prepared the presentation. I prepared the presentation here, so this work was done in a frame of our project with our industrial partner Compotech, who is a producer of filament wounded tubes. You can see it, yeah. And in the frame of our project, we worked on the technology of integrated loop technology joints. These ends. They are produced in a one step during the filament winding process, and the integrated loop technology joints have been developed to overcome the joint design issues such as hole machining and hand lamination. Another advantage of this integrated loop technology joint is that the production of such frames is rapid and cost effective. Here you can see some construction which were done with this type of loop joints. There's bicycle frame, tactical leather, composite battery cradle. Another possible application could be robotic arms, which are also produced using these composite tubes. And according to our industrial partner, collision often occurs during the operation of these robotic arms. So we were looking for some easy damage detection, easy way how to detect the damage of such components. Sorry. So we decided to use electrical resistance measurement. In literature, usually the contacts on composites are done in such a way that the surface is polished, and then the silver paste is put on the surface, or electroplating is used. So we suggested novel approach of electrical contact manufacturing. We used the carbon fiber toes with electrically contacted endings. We did nickel coating at the ends of the toes, fiber toes, and then we soldered the wires to the endings. The advantage of this approach is that we can integrate the contacts during the filament winding process, and there was also the requirement for the smooth surface of the specimen, because there has to be this cabling for the robotic arms on the surface. So for our experimental experiments, we used 4 specimens which were loaded for flexure loading. We used 4 specimens. Here you can see the configuration of the test. We used the strap for the loading, and then we did measurements also on 2 specimens which were loaded by torsional loading. Here are results of electrical resistance measurement during 3 cycles of flexure loading of our 4 specimens. you can see that for specimen 9 and 11, we can see dependency between applied bending moment and measured electrical resistance. Some dependency we can see also for this specimen 8, and here there is some problem with the electrical connecting between the specimen and the contact. Here are the measurements which were done to the final fracture during the bending. Yeah, you can see that the data differ quite a lot, but also the cracks on the specimens differ quite a lot. So I think we have to prepare specimens and with a defined damage, like cut or hole. But here I would like to present also these graphs. Here are results for torsional loading. At the left side, you can see results for 2 specimens which were loaded by 3 cycles of operational loading. You can see the clear dependency between the torsion moment and the measured electrical resistance. And here you can see the data for the final fracture. The change in measured electrical resistance was more than twice. The change was twice the size of the size, more than twice bigger than the measured data for the operation loading. So on these graphs, I would like to show a relative maximum bending moment for and torsional moment for specimens with electrical contacts here, and with electrical contacts and without electrical contacts. And you can see that the integration of the contacts in the structure during the bending did not affect the maximum bending and torsional moment. So here are some conclusions. We just did some preliminary tests. We prepared functional electrical contacts, and we integrated it during the bending process of the composite tube. The electrical connection to the structure was feasible and did not disturb the surface. Yeah, and we think that it's necessary to conduct more experimental investigations. Okay, thank you for your attention.